On warm days, moist air near the surface begins to rise, and this is how storms are born. Warm air is lighter than cool air. As it rises, it expands and cools, creating perfect conditions for clouds to form.
Forming. The rising vapor is becoming tiny droplets like me. As the cloud grows higher, it becomes a cumulonimbus, willow, the kind that produces thunderstorms and hail.
Whoa! I'm being carried up so high!
At higher altitudes, temperatures fall below freezing, yet droplets can remain liquid. We call these supercooled drops.
It's freezing here, but I'm still liquid. How strange.
When a supercooled drop touches a particle or ice crystal, it freezes instantly numb, forming the embryo of a hailstone.
These small ice pellets are called Graupel, the seeds from which hail grows.
In dry air, droplets freeze instantly. Air becomes trapped, producing a milky, opaque layer of ice.
When the air is moist, freezing slows down. The surface remains wet longer, forming clear, transparent ice.
Strong updrafts lift the growing hailstone up and down through wet and dry zones. Each journey adds new layers.
Every ride through the storm gives me a new layered wet. I'm growing like an onion.
I'm getting heavier and heavier, and nay, will I ever fall?
When gravity's pull exceeds the lift of the updraft, the hailstone begins its final descent.
Here I go, down through the storm!
Below the freezing level, the outer layer begins to melt rate. Some hailstones become wet or slushy before reaching the ground.
Large hailstones can reach speeds over 40 meters per second, fast enough to dent metal and shatter glass.
Be careful down there, Raindrop! I'll make it count.
When a hailstone hits a solid surface, its kinetic energy is released in a single violent impact. Some hailstones break on impact, revealing the layers built during their turbulent journey inside the storm. Each ring inside a hailstone tells a story. Clear layers form during wet growth, opaque ones during dry freezing. Hailstones range in size from tiny peas to massive grapefruits, depending on how strong the updrafts inside the storm are. When large hailstones fall, they can devastate crops, vehicles, and rooftops, causing millions in damage. The energy of a hail impact depends on both mass and speed. Double the velocity, and the energy increases fourfold.
I'm melting, turning back into water.
Welcome back, little drop. Your journey continues on the ground.
Heat from the sun provides energy to water molecules, causing evaporation back into the sky.
Up I go again, back toward the clouds.
As the vapor cools, it condenses into tiny droplets, beginning the cloud formation process anew.
Welcome back, Raindrop! We're together again!
The journey of hail shows us how energy, temperature, and motion shape the wonders of nature.
This endless water cycle, evaporation, condensation, and precipitation course, connects all life on Earth.
Under different temperatures, water changes form, from ice to liquid to vapor pit, yet it always remains HO.
The storm has passed, and the world feels new again.
Even the fiercest storms end in calm, and every storm teaches balance and resilience. From oceans to clouds and back again, the water cycle unites every part of Earth's climate.
I'm back again! ready for another journey.
The end.
I saw